There's so much stuff in Kubernetes. It looks big and scary, especially the API. So many different API calls and all of that, and pretty much the same with kubectl. And it feels like magic in many ways. I don't know if anybody looked at the code for kubectl, but it's a lot of complicated code. It's easy to get lost there. Not easy to know what's going on there, and there is a reason for complexity in kubectl and the layers of abstraction, but that's actually the part that scares new people from actually learning more. It's just, it's too much, overwhelming. What I want to do, I want to show you that kubectl is not magic, and you can build your own. It is possible, and you don't have to use Go. kubectl is built with Go, but it doesn't have to be. At least the version that you build doesn't have to be. There are a few fundamental concepts about the API that you need to understand in order to make sense of what kubectl does and what the libraries do. One of them is this concept of API groups. API groups are used to organize related resources and the operations around them. It's a way to evolve and grow the API in a more flexible way. The initial Kubernetes APIs, they're exposed through its own base path, and they have this virtual core API group. For the other API groups, you can actually see the API group name in the path, in the API path that you call. We'll see what it looks like later. If you've done anything with REST-like APIs, you probably know a lot about the resources, and it's very similar. It's the endpoints you interact with, where you send a GET or a POST method. It's pretty much the name of the resource in the path. The Kubernetes APIs, they use the standard REST-like HTTP verbs to do posts, gets, puts, deletes, and a couple of different flavors of batch. It gets more interesting with the objects. They have two flavors of objects: a basic object. There's a couple of fields for all objects. The kind field that describes the type and the version, the API version for the type, so you can encode and decode those objects. And then there are more complete persisted objects. They have additional metadata, additional fields like the metadata section that has the object name and other fields as well. But let's see what those constructs look like with the actual Kubernetes APIs. So I'm using the kubectl itself to explore the API groups. There's the role mode that you can use, and then you can point at a path. And if you point at the root path, it's going to list you the available API groups. There's a couple of highlighted API groups. The first one, /API, that's the original API, and that's what's called the core API group. And it has v1 as the version. So in a lot of the client libraries, you're going to see core v1. This is what it means. And that's where a lot of the original resources live. One of the other interesting API groups is the apps API group. That's where you have some of the newer resources, but let's see what we have there. So if we keep going and we make a GET call to the virtual core API group /API/v1, we'll see the resources that we have available there, and you're going to recognize some of them. You know about namespaces, pods, and nodes. Those are kind of the fundamental things. So that's one of the nice things with kubectl is that you can explore the actual API using the raw mode. And you can learn about what's there and what's available, and if you need to find a specific resource where it lives, which API group you can use that. If you look at the apps API group, and here, because it's it's no longer the core API group, the name is in the path, and the other API groups, they all are subpaths after the API's base path. So you'll recognize the daemon set and deployments resources. So with the, like when you make calls to the Kubernetes API, you're going to deal with the objects. And like I said previously, the basic objects, they have the kind and the API version fields. But the persisted objects, they have a whole bunch of other information as well. And one of the key pieces of extra data is this metadata section. That's where the object names live. For example, when you have your pods, the pod name, that's where it lives. The names are unique, so you can have two objects with the exact same name. And your client libraries, they're gonna encode and decode this data. That's what they're gonna get from the API. Now, obviously, going over the whole command set in kubectl is going to take a long time, but there's a small subset of commands that people usually use. The most basic set is just creating an environment, checking the pods to make sure that they're running. Looking at the application to see that it's okay, with the logs command and with the exec command, and that's the bare minimum. That's the MVP. So that's what the full sample code will cover once it's out on GitHub. But we're going to focus on a subset of that subset. But first, let's explore the internals to see what kubectl is doing and how it's structured, and that's going to be useful when you try to understand what's going on. All commands in kubectl, they're located in the pkg-cmd directory, and for each exposed command, there is a package. For example, for the logs command, there is the logs package, etc. And there are a couple of others. Internally, I don't know if you've used Go a lot, but Cobra is one of the most popular CLI packages that exists in the Go ecosystem, and kubectl uses it for its commands. And for each command that you make in kubectl, there's going to be a Cobra command structure set up with a run function populated, and most of the command handlers in kubectl, they have these three methods. One method to complete the command, to fill in the blanks in terms of adding defaults, etc., validating parameters, and the most interesting method is the run method. That's where the key business logic lives. So if you want to know what a kubectl command does, look for that run command. Now, here's an example for the for the get command. Now, it has a number of layers of abstractions there. You can see there's a factory involved, and there's a bunch of stuff happening. It's not quite obvious what's going on unless you know the code base. Yeah, it's tricky. Obviously, it's possible to figure out, but it's not obvious. You can't see any API calls and all of that. The other commands that are a little better, for example, the exec command here, you can see there's a pod client that gets the target pod information, and then there's a setup code to make a post request to the exec sub-resource, and there's a call to make that post. Still not quite clear, but at least it's kind of easier to understand what's going on. Obviously, again, there are good reasons for all of those abstractions, and it's possible to understand what's going on if you spend enough time. But it may take a while. So we need a shortcut. Luckily for us, there is a shortcut, and we'll use kubectl itself to reverse engineer what kubectl does behind the scenes. So we looked at that code. It wasn't obvious what it was doing, so we're going to approach it from the other direction. So there's a number of different levels for the verbose mode in kubectl. And if you use level 6, you're going to get a lot of logs, including the API calls that are made. So, and this is an example of the get pods command, and we see that it makes one API call. And if we look at the API call itself, we see that the call is made to the core API group because the base path is /API, and it's for version 1. So now we know the API group that it's calling. So that's a good clue. And then we see that it tries to access the pods collection, resource collection, under the default namespaces collection. So now we have a lot more clues. And here's another example where we use the logs command, and we see a couple of calls there. The first one is to check that the pod is there, and the second one is to get the container logs and Nginx container logs for that pod. So now we know the API calls that kubectl makes. Now we need to look for the libraries to make those calls. Here's a number of libraries. I picked the standard libraries for each language. So we have 3 languages: Python, JavaScript, and Go. I picked the standard libraries as the baseline for Python, the first one, and for JavaScript also the first one for JavaScript. And for Go, there's actually another one and somewhat official library, but it's not really used. It's experimental. I picked the standard ones and a couple of alternatives because those alternatives provide different interfaces. There are a number of other community libraries, but they're either not as popular, or they're less complete, or they don't really provide anything special in terms of the interface. So you might as well use the standard library. The official Python and JavaScript libraries, they use Swagger-generated code, which makes it easier to have full API coverage. The alternative JavaScript library has a different way to auto-generate the API client code. It's more API path-centric instead of being Swagger spec-centric. We'll see what it looks like, and it'll make sense when we look at the examples. The alternative Python library is different because it's not API-centric at all. It actually tries to expose a high-level interface that's similar to kubectl itself. So you don't deal with the low-level API constructs. Now, the official Go library is the standard for all other libraries. The other libraries are always compared to the Go library and its capabilities, so it's a good idea to do a quick overview there. The most important and the most used part of the library is the client set. The client set is a composite API client that has a bunch of mini clients for each API group. For example, there's a mini client for the core API group. The dynamic client is designed to work in a way that doesn't require specific Kubernetes object data structures. It has its use cases, but it's probably not something that you're going to use. The discovery client is useful when you need to discover the APIs available in your cluster dynamically. But because you're going to deal with the core API or maybe the apps API group calls, you probably don't need that client as well. There's also a bunch of advanced constructs there, like informers that help you build more sophisticated applications like controllers. For example, informers help you keep track of changes in your cluster, so you don't have to poll all the time. And there's a whole bunch of helper tools, to support port forwarding and all of that. Now that we know a little bit more about the Go client library, we have a little more context for the other libraries to revisit. So, like I said, all libraries have typed API clients. And typed as in, they have specific data types that they use for the API calls. Those typed API clients, they're usually Swagger generated. Now, it's nice, but those libraries, Swagger generated libraries, are low level. A lot more verbose and generally harder to use. And that is one of the reasons why I picked the other couple of libraries, because they provide an alternative way to represent the data types and the methods to call. The official Python and JavaScript libraries also have a number of additional features on top of the Swagger-generated code. For example, they have helpers to make it easier to watch for changes in collections and objects. And then the official JavaScript library has a bunch of helper classes that will help you build a kubectl-like tool. For example, they have a helper for port forwarding, doing copies, doing exec, etc., etc. And the official Python library also has the discovery client and the dynamic client if you need them. And again, most likely you won't need them. So let's see how we can use those libraries to make the same calls kubectl makes. This will be a short version with screenshots. I wanted to use the Jupyter notebooks, but there was a bug with the Go notebook. I didn't have time to fix it, so it's always good to have a backup. Now, this is the official JavaScript library example. We do a get pods call to get the list of pods, similar to kubectl get pods. To get pods, we need to be able to talk to the core API group. This is why the code creates a core v1 API client, and then with that client, it makes a call. It makes the list namespace pod call to get that list. And the name of the method here actually comes from the Swagger spec. So when the code is generated, it's going to look at the operation name, and based on that, it's going to generate the name. So, if you compare the user experience when you use kubectl with get pods, here you need to use this list namespace pod method, and you need to explicitly specify the default namespace where kubectl uses default by default. So the experience is different, the UX is different. And with the data object that you get back, it's because it's a thin wrapper, it's auto-generated, you have to access the metadata section yourself to get the pod name and the namespace and other fields and all of that. That's a side effect of the Swagger-generated code. Now, this is an alternative JavaScript library. This library is from GoDaddy. And if you look at the client creation code, it doesn't say that it wants to create a core v1 client. And that's because in that library, they use a different way. They auto-generate the typed client, but they do it in a different way. They still use the Swagger data, but they create, they make it path-centric. So when you look at the client call, there you see client.api. So this is a way how you tell that library that you want to access the core API. You specify the name of the path section, and then you say .v1, you say that you want to use v1 version, and then you specify the name of the resource, and then for that collection, the namespaces collection, you specify the resource name, and then you specify the pods collection. So this is a different way to interact with the API. Might be more convenient for you if you're a Node person. And here as well, you know, the pod object is a thin wrapper, so you have to access the fields from their native fields, native data structures as they're described in the Swagger spec. And then there's a kind of an output result there. So we have our Nginx pod, and it's in the default namespace. So now this is the official Python client library, and you said that you used the Python client library, so this will look familiar. And just like with the official JavaScript library, we ask the client to create a core v1 API client, which signals the intent to interact with certain types of resources. And as we've seen earlier, pods are in the core API group. So that's why we want to use the core v1 API client. And if you look at the name here, it is generated, but because it's Python, it's not camel case, it's snake case. But the name is pretty much the same. Again, it comes from the Swagger spec, from the operation name. And similar to the official JavaScript client, you need to be explicit in terms of specifying the namespace, and then you're accessing the fields like the pod name through this thin wrapper, data structure wrapper for the pod. With the alternative Python client library, it looks a lot different. This is the library that tries to provide a kubectl-like interface. So if you look at the code there, there's no client creation code. You just say package name, get, and then pods, very similar to kubectl. And then what you get back is a more custom data type, where you get the pod name as the top level field. You can still access the original field names in the metadata structure, but it provides a better abstraction there. So it feels like get pods in kubectl. And the final code example is with Go. And again, here we see this core v1 client request. So here we have the client set, which, like I mentioned, is a composite client where you have a bunch of mini clients. So you're asking for the core v1 mini client because that's how you can access the pods or namespaces or nodes. And then if you look at the methods, they look different. They don't look like the auto-generated methods. That's because the official Go library doesn't use auto-generated Swagger, auto-generated code. There isn't, like I said, there's an alternative Swagger auto-generated Go library, but nobody really uses it. So the UX there is nicer. The objects are also they're better defined. They have those fields like the name and namespaces as the top level fields. So you have a more custom and more tuned user experience when it comes to the client code. So we quickly learned about the key API constructs, like the API groups, resources. We learned about the API calls kubectl makes. You can discover the other API calls the other commands make. And then you can map those HTTP API calls to the library calls, and we looked at a number of library calls, 5 library calls to get pods, and you can do the same thing with other operations. And like I said, the full version of that subset of operations will be posted to GitHub.